Number 3, we have modulus s minus 1 less than half modulus s plus 3. You will observe in this case that we have two modulus or moduli on both sides. The plural of modulus is moduli. So note, in this case, note, this involves moduli on both sides of the inequality. On both sides of the inequality. In this sense, so we first of all square both sides to maintain the inequality relationship or symbol. So our solution in this regard will be for us to have s minus 1 squared less than half into the modulus of this, everything here also squared. It's a normal expansion. So s squared will be s times s is s squared, s times minus 1 is minus s, minus 1 times s is minus s, minus 1 times minus 1 is plus 1, less than half raised to power 2 is 1 over 4, open a bracket, then s times s is s squared, 3 times s is 3s, s times 3 is 3s, and then 3 times 3 is 9, close the bracket. Now, we can multiply both sides by 4 to remove this fraction. So we now have 4 into s squared minus 2s plus 1. By simplifying minus s is minus 2s. This will still be less than 1 multiplying this. We now have our s squared plus 6s and plus 9. Open the bracket once again to give us 4s squared minus 8s plus 4, and then bring the other term to the left hand side, minus s squared minus 6s minus 9. Everything is less than 0. You now have, in this case, 4s squared minus s squared, which will give you 3s squared, collecting like terms. Minus 8s minus 6s is minus 14s. And then you now have 4 minus 9 is minus 5. Everything is less than 0. In this regard, we are going to factorize this. Remember the factorization process. We have in this place 3 times minus 5 minus 15. Then we find the two factors of minus 15 that will give us minus 14. This is minus 15 and 1. So factorizing this expression, therefore, we will have 3s squared minus 15s plus 1s minus 5 less than 0. We will now group them as we have been doing, so that will give us 3s into s minus 5, close that. Then we also have plus 1, which is the obvious factor there, and this is s minus 5. It's less than 0. At the end we have s minus 5, and then we also have 3s plus 1 less than 0. Based on what we have been studying, this s minus 5 and 3s plus 1 less than 0 becomes s minus 5 equal to 0 or 3s plus 1 equal to 0. Because we want to find the point where the curve will cut or intersect the s axis. Here our s is equal to 5, and then of course our s is equal to minus 1 all over 3. I will quickly just use the graphical method. I will draw my graph. Just sketch it quickly. This is my S and this is my Y, and here is my 5 and here is my minus 1 all over 3. So, and because I know that S times 3S is 3S squared and the coefficient of S squared is 3, so our graph is going to look the U-shaped type. The parabola will be the U shape. So I'll go and then I'll have that. Now that I've done this, I will consider whether it is greater than 0 or it is less than 0. In this case, it is less than 0. So the solution will lie here. Solution will be in this region. This is where the answer is. So therefore, our answer will be minus 1 over 3 is less than S and S is less than 5, as the case